Hey, I'm Ender from Sunflower, and today I'm going to be showing you how you can make your very own 2D vertical platformer in Lens Studio, like this sample over here. So we're going to be covering a few key topics, such as screen transforms, prefabs, game flow, the leaderboard component, and 2D physics. So let's jump in. So just to note, I've already imported the 4 textures we're going to use for this lens, and they'll be included in the description, but if you want to add them yourself, you can drag them in or press the Import Assets button. Okay, so first off, we want to enable our 2D editor, which will allow us to edit the 2D screen objects. So we can open it up by pressing Window, 2D Scene, and then dragging it to wherever we want. And we want to create our player, so we're going to add a screen image, which will create an orthographic camera and a full frame region. And here we can set our player texture. So we're going to set that to our cat texture. So the bits from the side represent the anchor bounds, so we're able to scale these to move the image size and everything. And then the center point represents the anchor center, so you can move that if needs be, but we don't want to in our use case. So then what we want to do next is go into our assets, and we want to create a scripts folder, just to keep everything neat, and then create an asset, and then we're going to select scripting, JavaScript file, and we can name our file here. So player controller is what we're going to go for. And then we just can right click it and then press open an external editor. So I'm using VS Code, but any editor does work. So we want to get a reference to the screen transform of the player, as we'll use this to move it about the screen. When working with screen bounds, it's important to keep in mind that -1 represents the bottom left corner, and 1, 1 represents top right, with 0, 0 being the center point. And the way we're going to manipulate our screen objects is using the anchors. So we want to find velocity, which is the speed of the player in the y direction at any time, the gravity, so the rate it's going to be pulled down by, the jump force, which is how much it's going to bounce up by. Again, you can change all of these values, but these are just values that I found worked quite nicely. We have our target x, which is the position we want to move it to based on the finger. And then we have the movement speed. So this is how fast we want to lerp it over. And we don't want to move the player immediately to the finger position. Otherwise, this would make it quite easy to cheat and move easily from side to side. We want to make it smoothly follow the finger. So we need to create an event on the onMove event, touch move event. And then we want to get the finger position, specifically the X position on that finger tap. So we do that by doing event data, get touch position. And then we want to get the target X by getting our player transform, and then getting the screen point to parent point, and then we sub in our touch position there, and we will return a vector, and we just want to get the X variable from there. And we want to create an update event, which will allow us to actually update where our player is on the screen. So we want to get delta time, as this will allow us to help with the lerp, to make it smoothly move from one position to the other. So once we've got that, we want to get the player position, and that is just going to be the player transform. And then we get anchors, and then we get the center. So this will give us where it is in the screen bounds relative to its anchors, which are the bounds around it. And then we're going to set our velocity y, so this is how much it's moving up by incrementing gravity times our delta time. And then our player position dot y is going to be incremented by the velocity times delta time. Again, we're going to comment this out just so we don't have it for now. And then we want to get the difference in x, which is going to be equal to the target x minus the player position in x. And then we want to move it, so we're going to get player position dot x is going to be equal, or we're going to actually increment it by the difference times delta time. Times player speed times delta time, sorry. Cool, so now we want to actually update where our player is on the screen. So we do that by doing player transform, anchors, and then set center. It's going to be center point, and it's just going to be the player position that we've got. And we're just going to comment out the Y for now, just so we can see the cats smoothly move from side to side. But first, we need to add our player controller script to the scene, and we need to reference the player screen transform. So we can do it by dragging an image. And as we can see, nice and smooth from left to right, exactly what we want. And if we uncomment the Y stuff, we should see the cat fall whenever we reset the lens at the top. There we go, perfect. So we have basic movement handled. Now what we want to do is we're going to add a floor, so we have something to bounce off of. So we're going to do that by going in here, adding a screen image. We're just going to call that floor for now. And then again, we already have the texture in the project, which is grass. We want to make it fill width, so it fills the X dimension, and align it to the bottom. And we want to align our bounds to where we want to bounce off of. It's just that top bit. We don't really care about the leaves on the side. That's okay. So we're going to head back into our script. And what we want to do is first we want to add a reference to this floor transform. So we're going to do inputs and then screen transform again. And we're going to get the floor transform. We'll just call it that. Perfect. So then we want to add a function, and this is going to be called check floor collision. And we're going to pop in the player position at any given point. So this will just allow us to check, oh, are we hitting the player position? Because you can't use 3D physics for a 2D screen-based lens. So we're going to get the player size, and that is equal to the player transform. And then, as per usual, get anchors. And then we're going to want to get the size. So we can do lots of math with this to work out for colliding. So then we want to get the player bottom, which is just the player position in the y dimension. Take away player size dot y divided by 2. And then we want to get the floor position, which is going to be the floor transform dot anchors dot get center, as you will come to learn. And then the floor size as well, just like we've done above, with the dot anchors and then dot get size. Perfect. So now we want to get the floor top, as we want to check, are we colliding with it? So we do this by getting the floor position dot y plus, and then the floor size dot y divided by 2 again, because we need to get half of it. Perfect. And now we want to check, are we touching it? So if the player bottom is less than the top of the floor, then we know we might be inside. But we also need to check if the player bottom is bigger than the floor top plus minus a small offset, just so we can check we're actually kind of touching it inside it. So if we are, we then want to set our current velocity to the jump force. So we're bouncing back up. Now, when do we want to check this? We want to check this when we're falling down only. So when velocity is less than 0. So we've hit the peak and then we're falling back down. And we just want to check floor collision and pass in our player position. So as you can see, we can go back to our lens now. And we need to reference the floor transform. So we do that by just dragging it in. And perfect, we're bouncing. Amazing. What we also want to do is set a render target or render order of our player to 1. So this just means that we're going to go on top of everything. So as you can see, we go to the sides, which are a bit taller than the cat's still visible on top. So now we want to create a platform, which we do by adding a new screen image, calling it platform. And again, the asset's already in. So we just give it the platform image. And we scale it down so it's a nice size. Perfect, that looks good. And we can pop it anywhere in the scene. We need to turn it into a prefab. So we're going to make a new folder called prefabs. And we're just going to drag it into there. And then when it becomes green in the editor, you can remove it as you know it's a prefab. Perfect. So now we want to create a new JavaScript file. And we're going to call this platform controller. So within here, we want to get a reference to our prefab, which we're going to spawn as the platform. And then we also want to get a reference to the parent scene object, which we're going to parent these two to ensure that they're rendered in the correct way. So this is a normal scene object. We're just going to call it platform parent for now. Now I want to create some variables. So we want the platform spacing. So this is how far apart and why we're going to spawn the different platforms. You can set it to any value for now. Again, I encourage you to muck around with them, but we're going to go for 0.3 for now. We want the cycle threshold. So this is when we kill it when it's off the screen. So we're going to set it to negative 1.3. It's far enough off. We want a spawn threshold. So this is how far up we're going to spawn them at any given point. And we're going to make this equal to 0.8. And then we want the minimum x. So this is going to be the minimum value on the left and the right. Max x accordingly. So that's going to be 0.8 in both directions. And then we want to have a start y. So this is when we're going to start spawning them. And we're going to set it to 0.3. So it's just on the bottom half of the screen. And then we want to have a reference to our platforms, which will spawn. And then we also want to get the highest platform y. This will be very useful for knowing when to spawn things. So currently, that can be 0. So now we can create our first function called getRandomX. So this is just going to return a random float from -1 to 1, or actually -8 to 0.8, based off our min and max values. So this will be used when we come to spawning our platforms, because we want them to be in random locations most of the time. Perfect. So we've got that going. Now we want to create a function for spawn platform at, and we're going to sub in a x and y position. So we know exactly where we want to spawn it. This is just going to handle the spawning. So we want to create a new variable. I'm just going to call it new platform. and then we're going to get our platform prefab, and we're going to instantiate it to our platform parent, because we want it to be parented to that at all point. And now we're going to get the screen transform, which is on that prefab, as we need to use that to do different things with it, such as move where it is. So we call get component on the prefab we've just spawned, and we can sub in the component name we're looking for. So we're looking for a screen transform. So we can sub that in, and we should get the screen transform back. Now, obviously we should, no reason we shouldn't, but we're just going to add a if screen transform ref just in case. So in here, we want to set the ref to the spawn point, which is going to be, again, anchors, dot set center, and we need to create a new vec2, and we're just going to sub in the x and y position from our function. As well, we then want to get our platforms array, and we want to push this screen transform ref. This is what we're going to use to update later on. And then if y is bigger than our highest platform y, or highest platform, as we call it, change that back to highest platform y in a second. We want to set our highest platform to y. Again, realize I've made a typo there, so let me just go back and change it to highest platform y instead. Perfect, so there we go, and that is our spawn platform function pretty much done. Cool, so now we want to move on, and we want to create a function for initializing the platforms. So we're going to do this by, first, we're going to set our current y value to the start y value that we want to start at. And we want to get the highest platform, which is currently going to be at the start y value as well. And then next, what we need to do is we need to do a while loop. So while the current y is less than our spawn threshold, we want to spawn a new platform. So we call our new function spawn platform at, and a random x function as well to get a random x variable and y. And then we need to set our highest platform to the new y. And then what we're wanting to do is increment y by the platform spacing. So it moves up by that set amount every time. Perfect. And now we want to run this when the lens starts. So we want to create an event, and it's the onStart event we're looking to use this time. And then onStart, we want to call our init platforms function. So that should spawn all our platforms. Perfect. And if we go into our lens again, and we need to add the reference, we need to add a screen transform as the parent to our platforms. We're just going to call this platform parent. And yeah, now we want to add our script into the scene. And we want to drag in our platform parent and our prefab. And as we can see, there we go. Perfect. We have our platform spawning. Only issue though is by default, we're going to bounce on our first platform immediately. So let's instead make it fixed at the left and the right for the first two platforms. So we're just going to add a counter here called spawn index. I'm going to set it to 0. So first we want to check, oh, okay, is it 0? If so, let's just spawn it on the left. So we check, oh, is it 0? And then in there, spawn platform at, and we're going to specify, we're going to get the minimum x, and we're just going to add a 0.1 on it just to move it a bit closer to the center, and spawn at y. And then same thing basically with if the index is 1. So if I've jumped up once, or if we've once it's spawning a second platform, we want this to be a little bit on the right. So again, we're going to get spawn platform at max x, and then just take away 0.1. So it's not fully at the edge. And then again, we just want to sub in our y value there. Perfect. And then else, we just want to move our spawn platform into there, just so otherwise we spawn it normally. Can indent that. We need to remember to increment our spawn index as well. There we go. So if we go back, and you can see every time we reset it, those first two platforms are fixed, which will make it way nicer when it comes to actually jumping. But as you can see, we're not colliding. So let's add the code for that now. So we go back into our script, and this time we are wanting to add a new function. So this function is going to be called check collision. And it's going to take in the player position and the player size. And we're going to have to do some other 2D math to work out, oh, are we colliding? So again, remember, bottom left is -1, -1, and top right is 1, 1 in terms of screen transform. So first, we got our player bottom, which is the player position in y, take away the player size in y divided by 2. So this gives us the position of the bottom bit of the player. Player left as well, we need to get this. So we get their player position in it. .x, and then we take away, again, the player size .x divided by 2, because, you know, they're squares and rectangles.
And then player right is going to be our player position.x plus our player size.x divided by 2. So it's important to figure out in your mind how the screen transform works. Again, -1 to 1, 1, but try playing around, placing things in set positions, and just seeing how the numbers vary. And remember to try on different devices as well, just to make sure you're consistent. So we want to loop through all our different platforms. And for each of our platforms, first, we're going to get the platform from the array, and we just want to check it's there. So we're just going to run a quick check. Again, it should be absolutely fine, but always best to program like this. So if it's not, just continue, and we'll go on to the next one. So we're going to get the platform pos and this position, and this is going to be using the platform.anchors, since we're getting the screen transform, and then .getCenter. And then we want to get the platform size, which is again by now. So we've got the screen transform, we call getAnchors, and then we call getSize. Perfect. So now we want to get the platform top, which is just platform pos.y, take away platform size.y divided by 2. And then just the same thing again for the platform left and then the platform right. There we go. Cool. So now we want to check, is the platform top less than, -1, so it's off the screen, or is the platform position in Y, is it bigger than 1.7? If so, just continue. We don't need to worry about this because it's either off the screen on either dimension. So first, we can check, is there a vertical hit? So this happens if the player bottom is less than the platform top, and if the player bottom is greater than the platform top minus a small offset. So again, we're going to do 0.5 for that. Now, we want to check the horizontal hit, so much the same. So player right, is that greater than the platform left? And we need to do another check, is the player left less than the platform right? So if both of these are true, we are hitting the platform, so we want to let our main player script know so it can handle it and jump up accordingly. So we just want to return true. Otherwise, we've not hit anything, we want to return false. Oh, and as I can see, I've made a small typo there for player left. Let me just fix that. Yeah, there we go. E shouldn't be capitalized. Perfect. And now we want to make this accessible from other scripts. So we want to do script.function name equals function name. So this just allows us to call this function from another script. Exactly what we're wanting to do here. So we want to add a reference to our platform handler. So input script component, and then we're just going to call it platform handler. And now what we want to do with this is when we are checking our collisions with the floor, because we're falling down, we also then want to check our collision with the platforms. So first we need to get our player size, as the function requires that. So player size, again, player transform dot anchors dot get size. And then we want to make an if statement. So if platform handler dot check collision, and then we pass in our player position and player size. Yeah, so if that is true, then we want to set our velocity y to the jump position, or the jump force even. There we go. Perfect. So if we restart our lens, oh yes, we've got to give access to the script. There we go. And as you can see, we're bouncing. Perfect, but we're not scrolling yet. So that's what we want to work on next, ensuring that as we jump up, the cat scrolls and is always towards the center of the screen. Okay, so first we're wanting to add two new variables. So one has floor, we want to set this to true, and another one called has game started, or game started, and we're going to set it equal to false. So we want to add a new function. So we're going to scroll down to add this, and we're going to call it scroll world, and we're going to feed in the amount that we need to scroll by. So again, the screen bounds are -1 to 1, so we need to keep that in mind. So if we have the floor, then we want to get the floor position, and we want to get the floor, well, we'll do that by getting the floor transform, anchors, and then get center. And then we want to get the floor position and the y, we want to decrement that by the amount. And then we want to update our floor transform position. So floor transform anchors dot set center, and we want to give in our floor position again with the updated y. Now we want to check, is it off the screen? So floor position dot y, is it less than, and we'll just give an accurate value or a rough value. So less than 1.5 should be significantly off the screen by then. So we set house floor to false, which means no longer need to worry about checking that. And then we'll just set the screen object to disabled, just so we don't see it. Perfect. So now we want to add a new function called initGame, where we can set a bunch of start variables and start positions just before we actually wire up the scroll code. So for initialize game, or initGame for short, we want to add a few things in here. So first, we want to set house floor to true, and then game started, we're going to set this to true as well, as we've technically started the game. We're going to allow the person to jump with a jump. If we want to set a score, so we'll add a score variable at the top first, and we want to set the score equal to 0. This can also be used as a reset later if you're going further, and that will be included in the repo code. So we want to set the floor transform enabled to true, so we can definitely see it. And we want to get the floor position. So we do that again, floor transform, anchors, get center. And then we want to set the y value to -1, so it's always in the bottom bit of the screen. And then we want to get the floor transform, anchors, and we just want to update, so we're always at -1. We go set center, and then we sub in our floor position. Now we want to set the player default position as well. So we get the player position, player pause, there we go, which is equal to player transform dot get, or player transform dot anchors dot get center, and then bar player size equals, again, same thing, player transform dot anchors dot get size. Okay, and now we want to get the player position and y, and we want to set this to equal to -0.8 plus the player size in y divided by 2. And then we want to get our player position in x, and by default we just want that to be in the middle, so 0. And then player transform anchors, and obviously we're setting the center again. So it's set to that default point. That's perfect. Another thing we need to add is we want to set the velocity to the jump force by default, so it's always jumping. And this is important. We want to set a global touch system, and then we want to set the touch blocking to true. So this means that when we're in the Snapchat app, our swipes will not trigger the UI changes to spotlight, chat, that sort of thing, and instead they're just captured within the lens. So for a lens like this is crucial to add. So, and then on start initGame. Easy. Perfect. So now we want to add the code which will allow us to maintain a constant-ish y position. So we're going to get player anchor, a new variable, player anchor y. We want to set that to just under halfway. So we're going to go with -0.1. And then above the setting of our position, after we've updated the y and x variables, what we want to do is we want to do if player position .y is bigger than the player anchor.y. So this means we're high up. We want to get our scroll amount, which is going to be equal to our player position, again, .y, subtract the player anchor. So this is going to be the amount that we need to scroll by. And then we're going to set scroll world and then scroll amount. So this will scroll by that set amount every time. So that should work well. And we want to get our player position .y, and we want to set this equal to the player anchor, just to kind of anchor us down so we're not ever jumping way too high. And then we want to get our score, and we just increment that by score amount. Again, this might be a bit of a weird value, so later on when we set score, we're going to use some math to change it a bit. Anyway, in platform handler, we're wanting to add a scroll platform, which is going to take in the amount. So this is going to scroll the platforms by set amount. So highest platform Y, we're going to decrement by that amount because that's no longer the highest position. And then we want to loop through the array But this time we want to do it backwards, just because we might be removing things, and removing things from an array when you're going through it like you normally would can be a bit tricky and run into some issues with deletion and such. So for this reason, we're gonna go through the array in reverse. So first we want to get the platform, and then we want to check that the platform is valid. So if it's not valid, what we want to do is we want to get platforms, and then we want to splice. So we want to remove the current index, and then we can just continue on to the next object, or platform even. Otherwise, we can get the position, and that's going to be the platform anchors dot get center as per usual. And then with this, we set the y value by decrementing by the amount that we're scrolling. And then if this y position is less than the recyclable threshold, which is -1.3 by default, then we can get rid of this platform because it's way off the screen. We can kill it. So we get the screen object, and then we call get destroy. And then we want to splice it from the platform just so we don't run into any issues with it in the future. Perfect. But then if it's not out the threshold, we can update its position. Again, by the platform anchors and then set center to our new position. And then after that, we want to add in a while. So this is going to spawn in the remaining platforms. So while the highest platform is plus the platform spacing is less than the threshold, then what we want to do is we want to get the highest platform, and we want to increment that by the platform spacing. And we want to spawn a platform at random x, because we've done the first two, so we don't care about the x position, and then the current highest platform. Oh, wait, a mistake there. It's meant to be plus, not equals, and we need to make it referenceable by the other script, so we do script dot scroll platforms equals scroll platforms. Again, this is important. It makes it available to other scripts to reference. Perfect. So now we want to go and add that scroll platforms bit into our player controller script. So let's scroll down to our scroll world function, as this is where we're wanting to add it, and we do player platform handler dot scroll platform, and then we pass in that amount to scroll by. Perfect. So we're happy with this. All we need to do now is we need to add the reference to scroll in our main update function. So first we want to check, have the floor? If so, check the floor collision. Otherwise, we're going to continuously check. So now refresh the lens. We can see, oh, actually, we've got something wrong. Let's go back into our code and see what's up there. Seem to be complaining about get center of undefined. So we can check that in our platform handler. And, okay, looks like I did platforms instead of the individual platform. There we go. So as you can see, we're now able to correctly jump, and the floor goes away. We're scrolling down the different platforms, and we can just jump forever. But, you know, how good is infinite jumping if we don't have a score? But before we get to that point, let's add a game over first. So let's go into our platform handler. We want to create a new function, and we're just going to call this game over for now. And all we're going to do in there is we're going to loop through all the platforms that spawned and just destroy them. So we can do this normally. We can loop through in the normal way you would in an array. So we're just going to create our for loop there, and then just going to check the platform exists first. Should do. And then what we want to do is just platform or platforms I dot get scene object, and we want to destroy that. Perfect. And then we do want to just set the array to blank, just in case we do use it in the future. And then we need to make it referenceable by our main player controller script. So we do that by, again, script.gameover equals gameover. Now, another thing we want to do is within player controller, we want to add a check. So if game hasn't started, or if the game hasn't started, we return. So we don't want to do anything. Now we're going to create our function game over. So this is more, by default we're jumping, but then at the end we don't want to jump anymore. So we're going to set game started to false, and then we're also going to get the platform handler, and we're going to call game over there, which will allow us to kill all the current platforms in the scene. Perfect. So now we want to check, is the player, is it too far off the screen? Is the game over? So we'll do this. We'll get the player position Y, and we're going to say if it's less than 1.3, then game over. Oh, sorry, -1.3. 1.3 would be too high. There we go. So we should now see that after we jump and we die, perfect, everything disappears. Lovely. Now let's go ahead and use screen region, which we can add our UI to for being in the game. So again, orthographic camera, we want to add a new screen region, and we're just going to call this UI. We're going to hold all the UI there. And yep. So what we want to do now is we want to add screen text, and we're just going to call this score. Perfect. So once we go into our score, we can drag it to fit the sort of area we want. Now we want this quite small and at the side. It's just a little score to keep track. We're going to measure it in what we're going to call meters for this. So we can just pop in 0 for now. And we want to style it, make it look a bit nice. So I like to add a drop shadow, gives it that contrast. And a background, which we're going to set to 20 in each of the margins, just to give it a nice weighting. And same with the corner, just to make it all curved. Let's try 20. Yeah, actually, let's change that. And let's go into color and let's just set it to like a nice greeny blue. Perfect. I think that looks pretty good. So now we want to add, sort of drag it around in our scene, and then we're going to add some script references to it so we can actually make this change. So if we go back to our script player controller, and at the top, we want to add a text reference. So this will allow us to manipulate the value in that text. We're just going to call it score text for now. And then we update the score when we scroll. So we'll set it there, but we'll also set it in init game to 0, just so it looks nice. So score text dot text equals, and then we're going to go with just 0 meters. So 0 space m. Perfect. And then we're going to copy that so we can easily paste it up the top in our event. So once we've got the score, we're going to update it by score text.text and then math.floor, because it's a decimal value for now, and we're just going to do the score times 10. And we'll do this for other bits later. And then we're just going to add the .m on the end to give it that meter look. And we need to wire the reference up. So we just drag that in, reset the lens, and as you can see, our score is going up as we jump. Perfect, ideal. Although at the end, still doesn't look that pretty. So let's just make it look a bit nicer by adding another screen region, and we're going to call this, this is going to be when the game is over, so we'll just call it game over. And then we want to add some text to here. This is just going to be the final score. So again, we'll put a placeholder in here for now, call it final score, and we'll just give a value of 0 meters. And we want to drag this around. Let's make it, towards the center. Again, since it's got snapping enabled, it will snap nicely to the sides. There we go. Happy with that. And we'll rename it just to keep it nice, and we'll call it final score. Perfect. So let's wire this up too. But we also want to add a reference to the end game screen as a whole. So we might add more stuff there. So we'll call that game over screen. And then we'll also input the text. So, yep. Input the text. So we'll do ls input text. There we go. And then we're going to call this final score text. Perfect. So now we are going to go to our init game. And we don't want to see the game over screen initially. So we're going to set that enabled to false. And then what we want to do now is on game over, we want to set that enabled to true. And then we want to show our final score. So final score text equals, and we're just going to do final score. And then again, we're going to get our actual score and floor that times 10. So it's a nice round value. So floor score times 10. And then again, meters at the end, or m. Perfect. Now, the other thing we want to do is we don't want to show our current score text. So a way of disabling it is just getting the scene object. You can do this on most items, and then just setting enable to false. So it kind of keeps the code a bit cleaner. We don't have a bunch of references, but depending on your use case, may vary. Now, we want to reference our new references. So we have our game over screen, and we have our final score. And if we restart, we can see our actual score goes up, and then when we die, final score appears. Perfect. Looking much more clean. Now, let's add a background, make the lines feel a lot more fun. So we're going to go into our main region, and we're going to add another screen image. We'll call this background. And then we're going to set the texture to one already in scene. Again, project files in description. So with this, we can then drag it to the top, so it's rendered first. And we want to set the stretch mode to fill and cut. So there we go, it's complete background now. Fun, cool. But we also want to see the player. So let's add another screen image. This time we're going to attach it to UI. And we're going to call it player preview. So again, attached to UI, we'll just move it on top of the score. I mean, they're not going to counteract, but nice to have it there. And then we're going to set the render order to 1, so it's always on top of stuff. We're going to scale it down at the top there. Set the input texture to device camera, so this just takes the device camera texture raw. And if we add a masking component, we can set the radius to about 20, which will give it a nice kind of a rounded look. Now we need to make our image smaller, so we just drag it like that, place it, and we probably want it to be a square, so we'll just set it like that. Perfect, and then we can go over to stretch mode, fill and cut, and perfect. It's like a mini preview, exactly what we're wanting. So now when we play our game, we've basically got the full flow going. We have the spawning, the bouncing, everything, but let's have the leaderboard. Let's make it more fun. Everyone likes that sort of competitive nature. You can compare against your friends, and adding the leaderboard to a Lens Studio project is super simple. So let's head over to the asset library, which we can get to the top, and we just want to search for leaderboard, and it's the one on the right. So just the basic leaderboard component that we want. Already got it installed. So that is what we're going to use. So to add it to our scene, we just need to create a screen transform because it's 2D. And then we want to add the custom component. So we'll just name it leaderboard and add the component leaderboard. I've got 2 installed, so we pick the most recent. And then we can configure this, but all we want to set is the name right now. There is more you can do, such as the time it expires and everything, but we just care about the name for now. As you can see, pops up initially with friends played and a little button where you can view the leaderboard, which is perfect. So let's go and add some code for that. First off, we want to get a reference to the script component, as it is a script component of the leaderboard, and we're just going to call it leaderboard ref. So there's a few things we need to get from this. So we're going to create some variables such as leaderboard SS, which stands for side switcher. That's the wee dot you see when it comes up with the trophy icon. And then we want to get is leaderboard open, as we don't want to be able to move the character while the leaderboard is open. We want the leaderboard to almost pause the game. So in here, we're going to add a if leaderboard is open. Then we just want to return. We don't want to do anything. We don't want to update our position of our cat. Let's just leave. But then, if it's not open and we move, we want to get leaderboard side switcher, check it exists first, and if it does exist, then we want to hide the side bit and the leaderboard. So we just call .hide. Perfect, but we need to get a reference to the side switcher in the first place. So we do leaderboard equals, and then the leaderboard ref dot get side switcher. Now, we also need to know, is the leaderboard open or is it closed? So to do this, we call leaderboard ref, and then we do dot on show, and then we add an event. So it's just going to be adding a function, which is going to set leaderboard open to true. And then we need to do the same for when leaderboard is not open, and this is leaderboard dot on hidden. And then again, we want to make it so that leaderboard open is false, so that we can't move. There we go, on hidden, and then dot add function leaderboard open equals false. Perfect. So if we go back to our game and we restart, oh, we actually need to give a reference to the leaderboard first. So we just drag that in like everything else. Now you can see once it's open, if we try grab, the cat doesn't move. Bouncing up and down is fine. It's not going to hit anything. Perfect. So everything's going pretty well. But now what we want to add is actually submitting our leaderboard score. So once it's game over, let's get the leaderboard side switcher and let's show it. We want to be able to bring up the leaderboard. And we then want to get the leaderboard ref dot submit score. And we're going to put in our score here, which is just the score after we've floored it times it by 10. Again, super easy to submit a score to the leaderboard. Just that one line, leaderboard.submit score, and then the integer or value in. Perfect. So as you can see, we can now play, go up, and then leaderboard comes up once we die. And in the log, it's logged our submitted score. So that's it. Thanks for watching. Hope you managed to learn something new. And if you're looking for the fully commented code, or an example of how you can go further with this tutorial, there should be a link in the description which will take you to the files.